So this is 4.1b, radian and degree measure continued. We're going to look at how to change decimal degrees into degrees, minutes, and seconds, and convert degrees, minutes, and seconds into decimal degrees. So it's just like conversion. So let's talk about how we convert decimal hours into hours and minutes. So if I said convert 1.2 hours into hours and minutes, then you would know that you have 1 hour, and then that 0.2 hours, you're going to have to multiply that. You want hours to change to minutes. So there's what your conversion looks like. And you know in 1 hour, you have 60 minutes. So now you can see that the hours are going to cancel. Then all you would do is take 0.2 and times it by 60, and that's going to equal 12 minutes. So basically you multiplied by 60. So 1.2 hours is equal to 1 hour and 12 minutes. Just a reminder how to convert hours and minutes into hours decimals. So you have 3 hours, and then you're adding the 20 minutes. And this time we want the minutes to go back to hours. So conversion, you want minutes on the bottom to cross cancel, and we want to move to hours. And then you fill in what the ratio is. So there are 60 minutes in 1 hour. Now your minutes will cross cancel with minutes. And then basically what you're doing is you're taking the 20 and dividing it by 60. So 20 divided by 60 is 2/6, which is 1/3, or 0.3. So converting 3 hours and 20 minutes into just hours would be 3.3 hours. All right, let's look at Babylonian number system. The Babylonians were famous for their calendars and their number systems, and everything is based in 60s. So clocks are based in 60s. There are 360 days approximately in a year, and there are 360 degrees in a circle. So if you take 1 degree, you can take 1 degree and you can break it down into further parts where 60 minutes, there are 60 minutes in a degree, and each minute can be divided into 60 seconds. So there's 60 seconds in a minute and 60 minutes in 1 degree. So what we're going to do now is we're going to convert degrees to what's called DMS, degrees, minutes, and seconds. We're going to do that by multiplying by 60. So if you have 114.59 degrees, you would say, all right, well, I have 114 degrees. And then what I want to convert is this decimal part. So right now I have decimal degrees, 0.59, and I want to change that to seconds. So the conversion table, you're going to multiply that part by, there are 60 minutes in 1 degree. And then you can see that the degrees are going to cross cancel. Take on your calculator 0.59 times 60, and you're going to get 35.4. So this equals 35.4 minutes. So far, we have 114 degrees. We have 35 minutes. And now we want this 0.4 over here. We want to change that into seconds. So here we go again. We're going to take the 0.4, and that's 0.4 minutes, and we're going to multiply it by our conversion. So our conversion is going to say in 1 minute, there are 60 seconds. And you can see that the minutes are going to cross cancel. Take 0.4, multiply it by 60 seconds, and you are going to get 24 seconds. So 24 seconds. So 114 degrees, 35 minutes, and 24 seconds is your DMS, degrees, minutes, and seconds. Now this can be done in a second with the calculator. So let me show you how to use a calculator. So here's your graphing calculator. And all you have to do is you're going to type in your decimal degrees. So 114.59. And then you go to second and you go to apps. And DMS is option number 4. So I recommend you writing this down in your notebook. The keystrokes are down here at the bottom, and then hit enter. And ta-da, like magic, you have 114 degrees, 35 minutes, and 24 seconds. Now let's take DMS and let's change it to decimal degrees. Example number 2. So far we have 72 degrees. We have 13 minutes. And by the way, how we're going to get the 13 minutes into decimal degrees is we're going to just divide by 60. So that is my minute part. And now let's add the second part. So 52 seconds. Well, you remember that there are 60 seconds in 1 minute and 60 minutes in 1 degree. So you're going to have to divide by 3,600, which is 60 times 60. Do that and you will have your decimal degrees, which is 72.231 degrees. On the calculator, this one is not quite as easy, but I will show you how it's done. So you're going to take your calculator, and the first thing you're going to do is type in 72. And then you want this to be 72 degrees, so you hit second, you go to apps, and the degrees is option number 1. Then you're going to type in 13, and we want that to be minutes. So you go second, you go apps, and you pick option number 2. Then you would type in 52. And this is where it's kind of crazy because it's not under apps. It's down here above the add sign in green. So you're going to do alpha and then hit the add sign, and it's going to put in the seconds. Once you hit enter, it's going to give you the decimal degrees, which is 72.231. Our next example is a continuation from last class's lesson, or the last time you watched a video. The arc length is S equals R theta. So let's do a story problem. A circle has an 8-inch diameter. So if the diameter is 8 inches, then that means that the radius is 4 inches. Find the length of the arc. So when we're looking for arc, we're looking for S. And the arc, it's intercepted with a central angle of 240 degrees. So 240 degrees. The first thing we need to do is we need to change this degrees into radians. Now I'm going to show you the shortcut, so you could use the shortcut in class. I'll do it the long way right now. So we have 240 degrees. We're going to multiply it by the ratio. There's 180 degrees in pi units. And so the degrees are going to cross cancel. The zeros are going to cross cancel. And then you could actually take the 24 and the 18, and you could simplify each of those into 4 pi over 3. So 4 pi over 3. So that is the radians for the formula. So now we are ready to convert to radians. So we did that. 240 degrees is 4 pi over 3. We're going to find the radius. The radius is equal to 4, and then we're going to solve for s. So s is equal to r times theta, 4 pi over 3. And so s is the arc length, and it's equal to 16 pi over 3, and the units are in inches. And there you go. Now we're going to look at linear speed and angular speed. Linear speed is looking at distance. So you're looking at length over time. An example would be miles per hour. So the formula for linear speed is S, which is your arc length. Think of taking a circle and unwrapping it. So for example, you could think of a wheel of a lawnmower, if I were to put paint on it, as that lawnmower is going across the lawn. You're looking at how fast you're mowing over a distance. So linear speed is S over T, and you know S, arc length, is equal to R theta. So you could write this equation two different ways, or this formula two different ways, S over T or R theta over T, and that equals linear speed. Angular speed is simply looking at the number of rotations per time, or in this case, rotations per minute. So you're looking at the angle over time. So a lot of times you're going to see clock problems. So I just want to talk about the angles of a clock. If I were measuring time and I were going from 12 o'clock to 6 o'clock, this angle is going to be pi units. Now, if I were measuring from, let's say, 12 o'clock to 1 o'clock, this angle theta, well, we have 1, 2, 3, 4, 5, 6. So if we were looking at theta in terms of the clock, then you can see this would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So that angle there would simply be pi over 6. And let me just do one more example of time, because we see these all the time. Let's say that I was starting at 12 and ending at 7, and I want to know what that angle is. So I'm hoping that you know each number is pi over 6. So from 12 to 6 is simply pi, but then we go another unit over, which is pi plus pi over 6, or 7 pi over 6. So that's just helpful when you're doing clock problems. So let's look at this example. It says find the linear and angular speed per second of a 10.5 centimeter second hand. Notice each revolution around the clock is exactly 2 pi. So a second hand travels half the circumference in 30 seconds, or you could say that pi is going to be equivalent to 30 seconds. So looking at this, your linear speed is the radius times theta over your time. The radius, it told you, was 10.2. So you have 10.2. And now we need to look at an angle over time. So we said that theta, if I travel pi units, that takes me the time of 30 seconds. You could also put 2 pi over 60, so you want some sort of ratio. So now you can just go ahead and multiply 10.2 times pi and divide it by 30, and you're going to get 1.068 centimeters is the distance per second. Now let's look at angular speed. A lot of times you're going to see this W that represents angular speed. Angular speed is simply theta over time. So we talked about a clock and we talked about the second hand traveling that half circle in 30 seconds. So theta is the angle, pi is going to be traveled in 30 seconds. And so that's your angular speed. Now, angular speed, this is going to be radians per second. So if you wanted to simplify that, it's going to be 0.105 radians per second. I just took pi on my calculator. Pi, if you do second and then the raised to sign, no, it's, yeah, second and then the raised to sign, that's where you find pi. So you can plug in pi and then divide by 30. Now you could also do the angular speed in degrees if you wanted. So the angle in degrees is 180 degrees. We would be dividing that by 30 seconds. The zeros cross cancel, 3 goes into 18 6 times, which means I'm traveling 6 degrees per second. So you could do angular speed in radians per second or degrees per second. So let's look at example 5, but before we do, let's talk about angular speed and linear speed one more time. If you were riding a merry-go-round, your linear speed would be different if you were riding the horse on the outside of the circle or the carousel versus riding the bench in the center. Your linear speed would be different because your radius would be larger as you moved towards the outer part of the carousel. The angular speed, however, would be identical no matter where you sat in the carousel. Okay, let's look at example 5. Find the speed in miles per hour of 36-inch diameter wheels moving at 630 RPMs. First off, RPM stands for revolutions per minute. So those are your circles that you're taking over time. So looking at this problem, this is a conversion problem. So you start with 630 revs. So 630 revs, and you're going to divide that by 1 minute. And we want to convert revs to miles per hour. So you can either start converting your revolutions or your minutes. I'll start with my time. So again, the conversion is you want minutes to cross cancel, and minutes are going to go to hours. And you know that the ratio is there are 60 minutes in 1 hour. So now your minutes are going to cross cancel. The next thing we're going to do is multiply by, we want to get rid of revolutions. So in 1 revolution, now a revolution is a circumference around the circle. So 1 revolution, remember circumference is pi d or 2 pi r. So the diameter, you're going to need to know the diameter, and you're going to want it in inches. So it's in inches. So this is 36 pi inches. And again, I just used the circumference formula. So pi and then diameter was 36, and you want to include your units, which is in inches. So now you can see that my revolutions are going to cancel with my revolutions. But right now I have inches per hour. So I want to change inches to feet. So you can go from inches and then you can go to feet. And then after we do this, we'll go from feet to miles. So we know there are 12 inches in 1 foot. And now you can see inches cross cancels with inches. We're going to convert feet to miles. So feet to miles. And I always remember there are 5 tomatoes. 5 tomatoes. 5,280. 5 tomatoes in 1 mile. And so feet are going to cross cancel with feet. And now what you can do is just multiply across the top. Make sure you put pi into your calculator. multiply across the bottom, and then divide, and you have your conversion. So this ends up being 67, and we're going to round 3 places, 473 miles per hour. And that is your conversion. All right, example 6, I'm going to let you try on your own, and it's how many statute miles are there in a nautical mile? So give that one a try. Thing is, let's talk about what a bearing is. A bearing is going to be an angle. It's used in navigation. So whether you're flying or you're in a ship, bearing is going to be the course of the angle measured always from due north. All right. So if your ship is out here, the bearing is going to start from the north and it's going to go all the way around here. And we're looking for theta. So we know that the half circle is 180 degrees. We know the full circle is 360. So you could take 360. Notice you're 51 degrees short of 360. So just take 360, subtract 51, and you get a bearing of 309 degrees. So it's a 309 degree bearing. Now, another way that you can write bearing is if you wanted to, you could say what the bearing was if you wanted to start west and go north. So you would say, well, I'm starting west, and how far do you travel west till you get to the ship? You go 39 degrees. That's just 90, subtract 51. And then I'm moving towards the north. So that's another way to write bearing is I start west and I move north, and I went 39 degrees. All right, thanks everyone. I would like you to do the you try problems, number 1 and 2, and also make sure that you answer the reflection question.